Okay, let's have a look here at this. In a study, the use of macroinvertebrate communities as pollution indicators. The effectiveness of a numerical species diversity index to indicate aquatic degradation due to acid mine drainage was investigated. A high diversity index should indicate an unstressed aquatic system. 2 sampling stations were chosen, one upstream and one downstream of the discharge point. 12 samples were taken at each over the course of a month and gave the summarized results shown below. Earlier work suggested that an assumption of normality is reasonable. Formally test the equality of the standard deviations. So the null hypothesis is that the first standard deviation equals the second, or I think a bit more precisely, we say that the test is that the variance is equal. So it's not really that big of a difference, but technically we're saying that standard deviation squared, that the variances are equal. That's the null hypothesis, and the alternative is that they're not equal. So this is a test for equality of variance. Now the way we do this test is with a F statistic. So that will be, I guess it doesn't really matter which one we call 1 and 2, but I think usually we put the bigger one on the top. So we'll call that one 1 and that one 2. So that's sigma 1 squared over sigma 2 squared. So that is 0.872 squared over 0.508 squared. And let me get out the calculator. .872 squared over 0.508 squared. That's 2.946. Now the degrees of freedom on the top, I think in both cases the sample sizes were 12, so degrees of freedom is n minus 1. So on the top it's 11, and on the bottom it's 11. So if we go to our F tables for 11 and 11, let's have a look. Now, we'll use the usual alpha is 0.05. So in that case, 11 and 11. Oh, these tables are a bit weird. They skip 11. They go 10 and 12. Let me see if I can find better tables elsewhere. Maybe this one. Let's see. Try this one. Oh, they all skip it. No, I'm now a dog with a bone now. I really want to know for 11 and 11. Let me pause this as I go hunting. Okay, good news is I managed to find the tables that I wanted to use. Thank you, washington.edu. 5% critical values for F distribution, 0.05 significance level. Okay. Yeah, I think I have it here. So you just have to be a little bit careful here, because if you're doing a 5% critical value, you don't actually use the 5 table. I just realized that you have to use 2.5% because it's 2 tail. So just be careful about that because these tables quite often, their alphas that they give are for, you know, not exactly what you want. Like if it says alpha is 5%, that's just in one of the tails. So you're really doing a 2-tail test at 10%. So if you need a 2-tail test at 5%, then you have to look up 2.5% on these F tables. So if I go to the 2.5% tables, in fact 0.025, and look at 1111, I get a critical value of 3.43. Now, your value here, or my value here, 2.946 is less than the critical value. Therefore, we do not reject the null hypothesis. So we do have evidence here that the standard deviations are the same, that the variance is the same. Do not reject the null hypothesis at the 5% level. Okay.